Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy, and you can get a hold of us at 636-4357 or toll free 1-866-636-6284. You can email us at dothemath@kern.org or watch us online at dothemathonline.net or look for us on social media.
All right, so there's a lot of different ways kids can get a hold of us. And a lot of times when the kids phone in, they're speaking with you first before they get their problem on air. So I just wanted to say welcome to Do the Math on set finally. We finally got you out here. I know a lot of people are, see that? Nice round of applause for Cindy. So let the kids know where you work and the math or the levels that you teach.
Okay, I work at Warren Junior High School and I teach 7th grade math and 8th grade math.
All right. And
accelerated, level A's.
So you've been doing this for a while, and
Yes.
you've also taught some other courses besides what you're doing right now, because I
Yes.
know that you've taught geometry and
Yes.
things like that as well at Warren.
Yes.
All right. At Warren the whole time?
No. I worked at Stone Creek for a while, Thompson, and Thomas Jefferson Middle School in Wasco.
All right. Well, welcome to the set.
Thank you.
All right. So we do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. We'll be going out to the Bakersfield Museum of Art to check out what's going on downtown recently with the Art Museum. We have a very special guest in studio. We'll get to a couple of phone calls, but first, let's take a look at today's Math in the News. All right, so today's Math in the News has to do with sports. Are you a sports fan at all?
Yes.
Do you have a favorite sport you like to follow?
Football.
Football.
Yeah.
All right. Professional, college, high school?
NFL.
NFL. Do you have a favorite team?
I really don't.
You don't?
My son's Eagles and has been for years. But,
Okay.
So I root for them just so I don't have to listen to him complain. But
All right, well, I'm a New York fan, obviously, from moving out here, so my Giants aren't doing so well. So I figured, why not put the highlight on a couple of California teams? So we can see this is a box score from last weekend. So when the Rams were playing the 49ers, and the Rams got the win on that game. And there are a couple of things that you can look at when looking at a box score when you're trying to apply some different mathematics to it. So obviously, first, you can see that the game is broken down into quarters, 1/4, and then you have a total at the end. If you look at the first quarter, you can see that there was only one scoring instance for Los Angeles with a field goal at 6:34. So 6 minutes and 34 minutes had elapsed, or is that how much time is left? See, so there's two different things you can look at right there. If you take a look at the second quarter, you can see that the first score happened at 14:23 and the second happened at 12:59. So now we can take a look at that and go, that is the amount of time that is remaining in that quarter. So you can also take a look and you can practice elapsed time. So you can take a look at, all right, so from the time that this field goal at 10:05 occurred to the next score, 2 minutes and 30 seconds, how much time elapsed? So you can practice that for taking a look at time. Taking a look at the statistics, you can also take a look at where they have completions, attempts, and then interceptions, which is down here. And you can see how on one team they had 18 out of 24. Now, if we had 18 out of 24, we can think of that as a fraction. And if we had 18 over 24, how could we simplify that?
we could simplify it by 6.
Right, so we could simplify it by 6, so that we see that that would be 3 out of 4. So 3 out of 4 would be 75%, and that quarterback completed 75% of their passes. So then we can go all the way down to the bottom, and we can see some individual statistics, and we can see that the first one says rushing. So for Los Angeles, the person M. Brown ran it 13 times for 65 yards, and you can take an average of how many yards they rushed per attempt, and we can see that that would be 5, dividing 13 into 65. And you can see there are a lot of different stats. As with every other sport, there are a ton of numbers involved with it, and that's quickly just how you can take a look at a football box score, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio with us right now, we have Tanveer. How are you today?
I'm fine, how are you?
I'm excellent myself. Why don't you let everybody know where you go to school and what grade you're in?
I'm in 6th grade and I go to Stockdale Elementary
How long have you been at Stockdale Elementary?
for about 5 years now.
5 years, so you went there first, second grade, somewhere around
second
there?
grade, yeah.
Second grade? Everything good at Stockdale?
Yes.
Yeah. You like it all right?
Yeah.
Yeah. What are you going to miss about it? Because next year you're off to junior high. Because you've been there for 5 years now, right? Pretty comfortable, right?
Yeah. Well, some of my friends aren't going to the same junior high as me, so
So you'll miss
That's
some of
what I've
those
done,
people,
so,
right?
yeah.
Yeah, you know what? That's the thing. When you go to junior high, you guys kind of split up a little bit. A lot of you will go to the same one, but a lot of people go to some different schools.
yeah.
Well, how's math going this year?
Math is pretty well.
Going pretty well?
Yeah.
All right, well, you know what? You've got a couple of homework problems here. Let's go ahead and tackle one right now, okay? Head on over to the board. You and Cindy, you're going to work on this problem. All right, so we have -5. So start over on the left so you've got plenty of room. All right, so -5, open parentheses, 1 plus 2n, close parentheses, is equal to 15. So go ahead and solve that for us, please, and then explain to Cindy what you're doing as you go through the problem.
All right, so first you multiply -5 by 1, and so you get -5. Then you multiply that by 2n, which you get -10n, and then which equals 15. So I get this and subtract it from 15, so minus -5, and then I get 10 positive, 10,
So why don't you go
Yeah.
ahead and remember the subtraction rule for negative numbers?
yeah. So you subtract -5 from positive 15 and you get positive 10.
So what do you do when you see that double negative like that? What happens?
Oh, you change the sign
Okay,
from positive
and
to positive,
there you go.
and you get 20. So you get 20 from there, and then so you have -10, and you equals 20. So you get this. And then you change -10 to here. So you divide this with 10, and you get 2. Something's not right.
Okay, so let's go ahead and let's remember that since it's -10 multiplied by n,
Yeah.
you do want to reverse multiplication by division, but you still want to keep your 10 as a -10.
So then you get a positive 10.
So now we're doing positive 20
Yeah.
divided by -10.
Mhm.
So what's a positive divided by negative?
Negative.
Yeah.
So you get a -2.
How can we check it? Is this all the way down or no? Oh, there we go. There we go. There we go. Okay, how can we check it? So go ahead and finish putting your answer.
Oh,
So n equals,
n equals -2.
okay. Now how can we check it and make sure it's right? Let's look at the problem again.
So where there's an n, you just put a -2.
Okay, so let's go ahead and let's check it and let's make sure. So I'm gonna rewrite this, whoops. Let's rewrite this down here and then so we can move it so you can, and let's go ahead and, what's this mean right here?
That's a
What kind of math is that right there? 2n.
algebra.
So is it addition, subtraction, multiplication?
Multiplication.
Okay, so let's put times, and then go ahead and put in your -2 right there, because that's replacing the n, right? And then equals 15. That's my parentheses. So let's move this down so we have some room.
Okay, and so you have this, and when you multiply it, you get, or first let's multiply this, so we get -5.
Okay, so let's go ahead and do order of operations though.
Okay.
And since we don't have an n left anymore, we don't have to distribute.
All right.
We just want to do order of operations. So let's
Alright.
start with our parentheses. So let's save that -5 for after we do the parentheses.
So we get positive, or you get this. So you add the or multiply these, and you get -4,
Okay,
and then you get 1.
okay,
So 1 plus -4, which is -3.
okay. So let's go ahead and still, keep everything that we're not doing. Whoops. But let's. Okay. So go ahead and what you just told me. Go ahead and put that in there.
So -3.
Mm-hmm.
So you have a -5, and then you could subtract them, I guess.
Okay. So what's
So-
the math right here?
Oh, you multiply that.
Okay.
So you get -5, which equals 15.
Because you're multiplying, right? And so does it equal what it was supposed to equal?
No.
So what's it supposed to equal? What's the problem say it was
15.
supposed to equal? And what'd we get? If we multiply that, what do we get?
If you get positive 15.
Uh-huh. So does it equal what it was supposed to equal?
Yeah.
So then you know that your answer that you got. Oops.
Whoop.
What did I do?
Let's do this
that-
and
Whoop. Okay. Yeah, you do it.
we'll go back.
Okay, there we go.
There we go.
Okay. So the answer you got right here,
Yeah.
when we plugged it in and we checked it, we get the right answer out.
Yeah.
Then you know that your answer is correct.
All right, there we go. N is equal to -2. Nicely done. All right, we do have phone tutors available until 5:30 this Tuesday and Wednesday, as we do throughout most of the regular school year. Just a reminder, in San Luis Obispo County, that phone number is toll-free, and the number is at the bottom of the screen periodically throughout the program. But there are a couple of students that may want to pay special attention, especially if you go to one of the two schools that is in the head-to-head competition. You can see them right there, Rover Beach and Ocean View. So those two schools are competing. And the school with the most calls will have the top students. Head on over to Doc Bernstein's Ice Cream Lab. The secret facility is where they make it all, and they'll have a private tour of that facility. They'll even get an opportunity to win the golden ticket, an ice cream sundae for a month, for a year. So you get an ice cream sundae every month for an entire year. Would you eat that?
Yeah, sure.
I would eat that too. What about you? Would you
Yes,
eat that? I don't think there's anybody that would not eat that. Anyway, we have an opportunity right now. We're going to go out and about around town to the Bakersfield Museum of Art and visit with Devin.
Hey, thanks a lot. We're here live today at the Bakersfield Museum of Art with Do the Math, and we're going to take a look at how math applies to the art world in particular, and some of the jobs that entail applying math to making the experience of coming to a museum more appealing, more informational, and a lot more breathtaking. So I'd like to introduce to you today Rachel Magnus, who's the curator here at the Bakersfield Museum of Art. Rachel, thanks for having us today.
Thank you for coming to the museum.
So tell us a little bit about the Bakersfield Museum of Art, how long we've been here in this community, and what is the mission of the museum?
So the Bakersfield Museum of Art opened in 1956. We've been here for almost 63 years, and we are very proud to have a museum for that long in Bakersfield. It was opened with a very passionate group of people in the late 50s that have been able, some of whom are still involved in the museum.
So
Go ahead.
we are we're in the main exhibit hall of the museum, and there are exhibits that consistently rotate through, refreshed. And tell us a little bit about the exhibit we're in today.
Yeah, so this artist is an abstract artist. This is a survey show, so we have 50 years of work on display in this exhibition space. Showing 50 years of work in a small space is quite difficult. So we have to decide what works are really going to tell that story. This artist primarily like I said, is an abstract artist, but has always explored different types of mediums, meaning the different types of materials that he's using to create the work. Abstraction deals with different geometric forms, it deals with line, shape, form, and then we have color that plays a huge role in this artist's work. The artist's name is Charles Arnoldi, and he lives in Los Angeles, California.
Has he been around to check out some of the exhibits? I mean, obviously he's very familiar with the work, but to see the impact that his work has had over the years.
He has been to this exhibition. I worked with him directly. That's my role as the curator. I get to work with the artist or whoever is the trustee of the artist's work and put together a show that he and I both tell the whole story that we are trying to tell. He's been to the museum. He's given a talk. We actually will have him back coming up in December.
Excellent. You know, one of the things I noticed about a lot of the works here with Charles Arnoldi, especially as we enter into the main exhibit hall, as we go in deeper too, is the way that he leverages and uses geometric figures and angles in order of representation. We see a lot of squares and rectangles primarily as we walk in, and as you explore further, he does like to play around with other aspects of geometry.
Mm-hmm. Yes, so this work here is one of the earliest works. You see the same sticks that we were just standing in front of, but this one actually predates this. And most of the series in which are represented in this space start in a very basic format, that square that you're mentioning. So here we have a square. Well, it's not quite symmetrical because he's actually using sticks that he collected from nature. So there's an organic nature to these. But the shape that he is creating within this organic square is nearly symmetrical. So he is really playing with all elements of geometry. And to further enforce this symmetrical aspect of this piece, he has painted this wood different shades of blacks and grays. And the reason he does that is to make it look more like a brush stroke, to make it more look like a mark of a pencil. Because the first time he saw this work, he thought it mimicked one of his pencil drawings. And he wanted to enlarge that.
That conversation kind of takes me to another piece that I had noticed as we entered in, which kind of lends into our conversation about geometry and structure and playing around with that format, as well as shading. And it's this untitled piece here from 1972, which appears to have been formatted on graph paper.
Yes. And this is one of his actually preliminary sketches. And he's using this graph paper as well, the material he's actually working on is he's wrapping wire around sticks and seeing how much bend he can get into those. And this is just playing with that shape that he is going to create.
So this ends up being an abstract sketch of something he would physically build with materials.
This will be a sculpture eventually.
But using that graph paper as the format to work within, to express and visualize to himself what this would look like in real life.
Mm-hmm. It's a great way for him to actually measure something without necessarily having to.
So as we go into the further ends of the exhibit here, we see him start to scale out more into what our viewers may traditionally be familiar with as far as what they perceive art to be, beyond simply building with materials, now onto paint and canvas.
Yes, here we have a very straightforward paint on canvas. What's interesting about this piece is, well, a lot of the surface has been left exposed. We see the linen, which what that does is makes all of these shapes really pop out. So whenever you look at them, they almost seem to float and levitate above the canvas.
So, you know, we look at a lot of the work of this artist, and you know, this is, like you said, over 50 years worth of work. Of playing around with shapes and expressing general concepts, as well as how they interact with light as well. What is your biggest takeaway as far as the geometry as a structure of art, beyond simply the artist here, but how artists generally utilize geometry and angles in communicating ideas and expressions?
Well, I think it's, a fundamental elementary level. It's how we start out making any art. The line is the most basic form of communication. Each child starts their first drawing, their first letter, their first number with a line. as artists develop and advance, they have to advance those skills, but geometry, lines, shapes play a vital role. And it also plays a vital role in what I do in laying out this exhibition.
And that's a big part of the curator's role as well, is not just to collect the art, but make it accessible for viewers and to build this experience as you walk through the exhibit hall, to really tell the story and allow as many people as possible to interact with the story being told. So when we come back, we're going to talk to Rachel a little bit more about how she utilizes math in her role as a curator here at the Bakersfield Museum of Art. But for now, we'll send it back to the studio. Mike, back to you.
All right, thanks for that, Devin. Hey, do remember we have phone tutors available until 5:30. We've got Tanveer, a 6th grade student from Stockdale, working in studio with us. And right now we're going to go to the phones for a 6th grade student from Reagan Elementary. Caitlin, how are you this afternoon?
Good.
And are you working on equations like Tanveer is?
Yes.
All right, as soon as you're ready, let's hear the problem that you're working on.
Negative 5n plus 17 minus 8n equals 56.
Negative 5n plus 17 minus 8n equals, what was that last part?
56?
66?
56, I think.
56, okay. All right, so tell me how you would start this problem.
So I first did negative 5n minus 8n, which is negative 13n.
Okay, so you went ahead and you simplified by combining your like terms, and then what'd you get?
Negative 13n.
Okay.
And then I had equals 56 minus 17.
Oh, so you already did something with the 17 as well?
Yes.
Okay, so let me go ahead and, so I went ahead and I combined your like terms like you told me, and then you said that you subtracted 17?
Yes.
Okay.
So I had negative 13n equals 39.
Okay.
And then I divided each side by negative 13.
Okay, and how'd you know to divide?
Because it's opposite.
It's the opposite operation or the inverse operation. And so you divide that to both sides, and what did you get?
N equals negative 3.
Okay, good job. So how can we check that?
You would plug in negative 3 where there's an N.
Okay. So let's do that. Let's go ahead and we'll take the original equation, negative 5n plus 17 minus 8n equals 56, and we'll put the n's as negative 3, right? So I'm going to do it off to where I have some room here. So negative 5 times negative 3, and then what?
Plus 17 minus 8 times negative 3.
Okay. Ooh, I'm going to run out of room. Hold on, I'm going to erase something here. Oh yeah, I can just do this. Okay. Go ahead. Equals what? What's it supposed to equal?
56.
Okay. Okay, so let's go ahead and what's negative 5 times negative 3?
Negative 15.
Well, what's a negative times a negative?
A positive.
Okay.
So positive 15.
Okay. And then since we're doing order of operations, what's our next part we're going to do?
Negative 8 times negative 3.
Okay, and what does that equal?
Positive 24.
Okay. So now we have positive 15 plus 17 plus 24. And so if we add that up, what are we going to get?
56.
So let's just double check and make sure. Whoops, that looks like a... Okay, so let's see. 7 plus 4 is 11 plus 5, 16. We carry the 1, 2, 3, 4, 5. Yep. And that's what it's supposed to equal, right?
Yes.
Okay, so that's how you know your answer is correct.
All right, nicely done on that, Caitlin. Congratulations. You also will be receiving a meal of your choice courtesy of our friends at Grillenberger. So we hope you enjoy that right there. All right, young man, I saw that you had negative 3 because you were working on it at the same time, so it's nice that everybody's coming up with the correct answer there.
Yeah.
Now we're going to move you on. We're going to go from number 2 to number 9. We're going to skip all those other ones in there, all right? So let's head over to the board and we'll go ahead and work on this next one. So first thing we have is 12, and then open parentheses, and you're going to have M plus, now you're going to have a fraction, 1/2, close parentheses, is equal to 24. So if you're a little stuck on this or maybe not quite sure, Cindy's right there to help you out.
All right, so first you would multiply this, so you get 12m, and then you multiply 12 by half, so you get 12 over 2, and if you want to simplify it, you could make it 6, so should I make it 6?
Yeah, let's make it 6.
Okay.
That's easier to work with.
All right, so we got 6, which equals, I put a Z, which equals 24.
Okay, so let's go ahead and let's put in the symbol that we should have right there.
Okay, so we get
So is the 6 positive or negative?
Yeah, positive.
Yeah.
All right.
I'm gonna go ahead and let's move this down just so we don't run out of room as you're going.
All right. And so I would get 6. So you get 12m.
And what are we gonna do with the
equals-
6?
You're gonna subtract it from 24.
Okay.
So you get 24 minus, and so when you bring it over here, you'll change it to a negative. So I change it to a negative, so I get -6.
Okay, so let's stop for just a second. Okay, so when we did 12 and we did times a half and we got 6, when you got that, right? And it was addition, it's adding 6, right? So when you're working on equations, you want to do the opposite operation. So what's the opposite operation of addition?
Subtraction.
Right, but you don't have to change the sign also. You just have to change one thing, because really, if you put this back to what it would equal, it would equal back to a plus.
Yeah.
Which is not what you want. You want to
Right.
make it end up as the opposite.
So make this.
Yeah, or just erase it. You know.
Okay. And then so you subtract it and you get 18.
Okay.
So you get 12, or you get.
Yeah,
you get
this is
18.
still here, so 12m is still here.
Okay, so you get 12m equals 18. So you get 12m, or 12, and you divide it by 18, so which is going to end up as a fraction. So you get m equals 12 divided by 18.
Okay, so I'm going to pause you for just a second. So when you look at this, and you're trying to like make sure you're keeping track of everything, because you have the right operation, it is division. So which one of these numbers, 12 or 18, which one's multiplying with m in the original part right here?
The 18.
Is 18 multiplying with m right now?
Yeah. Or-
Okay, if the 18's over here, right?
Yeah.
And then
Or-
the m's over here, which one's actually against the m? Because that's the part that means multiply. So this is the part that we want to divide by. So we actually, this is why sometimes as you're doing these, it's good to kind of use some of the skills you'll use when you get into higher algebra, which is to draw it as a division fraction bar.
All right.
Okay, because this is a little bit different than this.
Oh, so you switch it.
So yeah, you just had your order reversed, okay? And also, it doesn't, notice it's not going to divide evenly, right?
Oh, yeah.
So that's how you can get your fraction in the right order too.
That won't work. Okay, so we get m, and then you get 18 18 over 12,
Okay.
and then so you can do that, reduce that to 1 and half.
Okay.
So m equals 1 1/2.
Okay, so just in case anybody else is like, whoa, how do you jump from 18 over 12 to 1 1/2?
Oh, I reduced.
You want to go ahead and maybe just
yeah.
tell them how you got that?
Okay, so it's you get 1 because 18 over 12, so you get 1 and 6 12, which is when you reduce it, you get when you divide these by 2, and you get 1 and 1/2.
Okay, so just in case anybody was like, what?
Nicely done. Now, don't go anywhere because your paper doesn't even have 1 1/2 as an option. So mixed number is out.
Yeah.
So you have an improper fraction right now, 18 over 12. You need to simplify it and let it remain
Improper.
in that form.
Okay, so instead of making a mixed
So-
number, go
Okay.
back to here and just reduce it.
So 6 over 4, you could do 6 over 4.
And then that reduces some more.
And
So
then-
put 6 over 4 first. So that's what you got first, right? You divided each of them by
Yeah.
3? Okay, now simplify it again,
all right.
if you can.
And you could divide it by, or simplify it by 2, so you get 3 over 2.
And can you simplify that anymore?
No.
No, but you can rewrite it in a different form, which is
Yes.
what you did with the mixed number. So that is what I think they were looking for on your homework, because they had only improper fractions and, well, a proper fraction on there as well.
So it could be m equals 1.5, or it could be m equals 3/2.
There you go. Nicely done. Well done on that, Tanveer. Thank you for that. All right, we do have phone tutors available until 5:30. We'll be heading back out to the Museum of Art. We'll do all of that right after this. Today we're on the Central Coast. We're at Grover Beach Elementary, home of the Golden Gophers, and we're here to... All right, today we're in Grover Beach at Grover Beach Elementary. We've got some students in 4th grade as well as 6th grade, and we're going to work with some manipulatives. Have you guys ever worked with objects in math before?
Yes.
All right. So do you like that more, or do you want to just do stuff out of the book?
I usually do it out of the book. I like both.
But would you rather do the manipulatives today?
Yeah.
All right, let's do that. All right, so how many of you guys have ever used these? These are polydrons. Have you guys ever used these? A little bit?
Not ones that look exactly like that.
Well, that's all right. There's a lot of different types, all right? So here's what we're going to do. Just to kind of start passing out a lot of pieces, spread them out, all right? Get some in front of each of you. There's a lot of different shapes and sizes, all right? So here's what I want you to do. First of all, I want you to make sure that you can put them together. So if you have them on the table like this, they kind of slide together like that, and then you kind of like feel and hear a little snap, and then they're together, all right? And then they can move like that. So just practice putting them together like this, all right? So you can just take two pieces, all right, and put them together, all right? They kind of snap together. There you go. See, they're not going to go right up to each other as long as you get them like that. There you go. So what you want to do is, see how these two are together? You want to flip this one so it's on the opposite. There you go.
How
Got it?
exactly do you?
Let me come on over and help you out. All right, so these two. Because right now, you see how those are right exactly opposite, the same? You want to flip one so that they're opposite, and then you just go like that. Squeeze it a little.
Oh, I see.
And now it's together, okay? Perfect, flip that one, squeeze it together. There you go, do you hear that snap?
Yeah.
So here's what I want you to do. I want you to make a 3D object. Because if it's down like this, right, that's just 2D, right? So I want you to make something, see now you're getting into the 3D, right? So what I want you to do is see if you can put a top and a bottom on that.
I can make a tiki.
Make anything at all that you like. Just to get the idea of how these things fit together, how they work, and different things that you can make. You have the right size on there? See, that one's a little larger, isn't it? There you go. And if you need a piece and it's not out, just go back in here and find what you need. Need another little triangle like that? The green or the blue will work because they're the same size, just different color.
I finished it.
There you go. And what did you make?
A square. It's a cube.
There you go. That's exactly what I was looking for, because this would be a square,
Yeah.
but now that would be a...
Cube.
And what's the difference?
This one's 3-dimensional, now it's 2-dimensional.
There you go. And what did you make?
Rectangular prism.
Give it to me right there, sister. A rectangular prism, right? Now, what makes that a rectangular prism? How did you know that that was the proper vocabulary for that?
Because, well, actually, I don't know, because it's shaped, because if you take this part out, then, well, okay, so it has 2 squares, and 1, 2, 3, 4, rectangles, so it makes it a rectangular prism.
There you go. Perfect. That is exactly what I was looking for right there. Well, these guys here at Grover Beach Elementary are working on just how the polydrons work together, experimenting with some of the different 3D shapes that they can make, and we'll put forth a challenge to them coming up next. Well, big thanks to Mr. Snyder and the students over at Grover Beach Elementary. A lot of fun working with those manipulatives and being able to make things and then see how we can apply that to different mathematics that we were doing over there with them. We do have phone tutors available until 5:30. We've got another phone call to get to. We've got Tanveer in studio, but right now we're going to go back out live and about Bakersfield Museum of Art and visit with Devin.
Thanks a lot, Mike. Back here at the Bakersfield Museum of Art, taking a look around, and now we're going to talk to Rachel Magnus, our curator here at BMOA, about how math applies to her role as curator. Because it's not just about finding the right works of art, it's about framing them to allow viewers to really appreciate them more. So, what kind of role does math play in that?
So much of what I do, I do have to learn about the artist. I have to figure out what is going to be the most interesting to the viewer. But a lot of it is deciding how the viewer is going to experience the room. So before the work even gets into the museum, I take a Illustrator file of the space and start playing with the pieces and thinking about what pieces are going to really work well next to each other, what pieces will amplify the piece next to them, which pieces cannot be next to each other because the colors don't work next to each other or there's shapes that might be competing. And then I think about how to evenly space a room, how to create kind of pathways that will lead a viewer through the space.
So you build the workspace before you actually build the workspace. You have a virtual setup, and then you're able to lay everything out based on the vision you've constructed, using some of the measurements you anticipate based on the information you've already received. So, what are some of the key things to look out for that maybe if you've been to a museum you hadn't noticed the first time?
I think you can learn a lot when you actually start thinking about why a curator would have put one painting next to the other. There's always going to be a lesson there. Sometimes a curator might put two paintings next to each other because they really want you to notice a certain color. And when they're next to each other, that really comes forward. Another thing that might be just a subliminal thing, but you realize a space is very calm. And it's because paintings are evenly spaced in the room. There's a same line going through. While the top of the paintings might not all be at the same level, the center of those paintings takes our eye and it guides us through the space.
And that follows through with the captions as well, the little bits of information that patrons of the museums may need to help them appreciate and understand the work more. And in addition to having the caption cards next to the paintings, there will be larger prints generally placed on the wall or such that you have to sort of plan for, install, and design. And you've got tools that you use to make sure that that is aligned appropriately as well.
Yeah. So we pull out, each painting will have a little didactic information is what we call it, that which has name, date, the artist's name, and maybe some important information. We pull out very important information to put directly on the wall. This here is an example of that. And this is called vinyl text. And we have a vinyl printing machine here. What we do is after I have written this text, I work with our graphic design department and we bring it into an Illustrator file, size it to this specific space, and then we put it through MaxSign, which is a program that we use, and print it out. After we do that, we have to manually go in and remove all of the negative space because the only lines that are cut are the outside of each of these letters. So we have to pull that out, and then we use contact paper and place it on the wall. It's very important, as you can imagine, that we get this very straight, because if there is anything slightly askew, that's where your eye is going to go. So we use this level, this laser level, which has changed the way we install this vinyl lettering.
So what's nice about this laser level is that it guides the lines of text across not just a vertical axis, but also a horizontal axis. And you may actually use this as kind of like a coordinate plane in a sense, where here's your origin and how does everything align within the quadrants.
Mm-hmm. Yeah, and the center of this will align with the center of the painting next to it. And so often we'll use this x-axis and align that up to the center of a painting.
And one of the things you mentioned about the center of the painting is that there is a standard in the art world about where the center of a painting aligns on a wall. Is that based on a ratio, or is that based on eye level?
Eye level is exactly it.
Okay.
And most of the standard in museum practice is 55 to 60 inches.
So about 5 feet.
About 5 feet is that where we're putting our eye level at. And we have a great equation, the way that we do that. I could go through that with you.
Oh, that'd be great.
All right, we can go here.
Let's see.
Is there another one we should do?
You know what? Let's go with this bag of Fritos
Isn't
piece
that a
here. It's
great
always very
painting?
popular. Yes.
It is always very popular. So the way we do this to make sure that each painting is hung with the 60 inches just to the center, our first equation, or the first number that we'll get, is the exact height of the painting. So we have 12.5 inches.
Okay.
In order, then we will take the back of the work, go to the center of that frame. You also can see where the artist wrote, which is always kind of fun. To Rachel Magnus, I curated this show. So we have just 2 1/4.
And that's off of the wire in the back, not necessarily a point.
So
on the
because
wood
that's
here.
how far down it'll hang. So that's
Okay.
where our nails, we use screw here, will have to go. So we have that 12.5. We'll have to divide that by 2.
Okay, so that
I'm gonna have to
brings
have you
us
help
to-
me.
Sure, 12.5 divided by 2, so that's going to be about 6 1/4.
Yes, and then we will subtract 2 1/4,
So that's going to give us 4.
and we will add 60.
So 64.
So 64. So what that does is that means that 64 is going to put us right in the center, and that is where our screw should go. Let's see if we did it right. See
Just
that?
about there, right on the money.
Right on the money, 64.
So by putting it 64 inches from the floor, you're going to guarantee that this piece is at eye level at about 60 inches.
And not just eye level, but the same level as every other work in this space.
That's phenomenal. That was a wonderful exploration there. So when we come back, we're going to talk to Rachel about how you can become a curator, how you get into this line of work. But for now, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, Devin. And a little bit more math involved than what most people would think at an art museum. We'll visit with Devin in just a little bit. We're going to make you do some more work, but not equations anymore. But we're going to let you take a break right now because we're going to go to the phones. And Tierra, how are you this afternoon? Hello, Tierra.
Hi.
And you're doing an estimation problem, is that correct?
Yes.
All right, as soon as you're ready, let's hear that problem.
Okay. So it says 60% of 52.
So 60% of 52, and you're estimating. Correct?
Uh-huh.
Okay. So, whoops. Since we're estimating 60% of 52, what's 52 close to that we could use for an estimate?
50?
Okay, that sounds like a good estimate. It's pretty close to 52. So let's use 50 since we're estimating. That means we don't need an exact answer. We just need something close. So we want to find 60% of 52, but we want to do it as an estimate, which means we want to kind of be able to do mental math or something where it's quick that we don't have to actually write down and calculate out. So I'm going to ask you a question. Do you know how to find 10% of a number?
Not quite.
Not quite? Okay, so let me give you some examples and just see if you can get the pattern. So 10% of 70 is 7. 10% of 88 is 8.8. 10% of 90 is 9. Do you feel like you have a pattern there?
Yeah.
Okay, so what do you think 10% of 50 is?
6.
Not quite. You still need some more hints?
5?
Okay, so did you find 10% of 50, or I think you cut out a little bit? Whoops.
Is it 5?
Yeah, there you go. I didn't hear you if you said that. Whoa. Okay, I just changed colors. Okay, so if 10% of 50 is 5, how could we find 60%? How many sets of 10% make 60%?
6.
Okay, so let's do, since 6 times 10% would give us 60%, and we know 10% of 50 is 5, what's 6 times 5?
30.
30. Do you understand why I did 6 times 5 to get my estimate?
Yes.
Okay, so we're calculating 60% of 50 is about 30 as an estimate. Okay, well actually 60% of 50 is 30. And so we want to see if our estimate is actually a good estimate for 60% of 52. How do you multiply, or how do you solve a percent problem if you're trying to actually solve it and not just get an estimate? Like if we wanted the exact answer, do you remember what to do? Have you guys learned that yet?
No.
Okay, so what is, do you know the decimal for 60%?
6.0.
Close. Since it's like 60%, which means 60 hundredths, 60 out of 100, do you know the decimal for 60 hundredths?
0.6.
Okay, so 0.6, yeah. You don't have to get all the extra zeros. So 0.6. And then do you know what the word of means as a math operation?
Dividing.
Close. What's the inverse of division?
Multiplication.
Yeah, of means multiply. Anytime you're working with percents and you want to find a percent of a number, you basically multiply the decimal with the number. And so we have, if we multiply 0.6 by 52, we can get the exact answer and see if our estimate is a good estimate. So let's do 0.6 times 52. All right, so I put 52 over 0.6. What's 6 times 2?
6 times 2 is 12.
Okay, so, and then we carry the 1 up there. And then 6 times 5 plus 1. What do we get for that?
31.
Okay, and then do you remember how to bring your decimal from a multiplication problem, how you count it out? Do you remember that part?
Yeah.
Okay, so where should I put my decimal? Right now I have 3, 1, 2. Where should I put my decimal?
31.2.
Okay, so the exact answer is 31.2, and our estimate was 30. Do you think our estimate was pretty good?
Yeah.
Okay, so there's our estimate, which is what you were asked to do, right? Find the estimate. We got 30. We did the exact answer to make sure our estimate was close, and it was. Does that help you? Does that answer your question?
Yeah.
All right,
Okay,
nicely
great.
done, ladies, and congratulations, Tierra. You've got yourself a couple of tickets, 2 passes to go to any CSUB athletics event of your choice. So right now they've got volleyball going on, soccer is going on, swimming, diving, basketball is going to be coming up, baseball and softball in the springtime. So congratulations on that. We do have phone tutors available until 5:30. Tanveer is anxious and ready to get back to work. So over to the board, young man. Equations are done. And since they were just working on estimating with percents, here I'm going to give you an option. You're going out to buy a brand new pair of shoes, sneakers, whatever you like, all right? How much are those going to cost?
80, 90 bucks.
Well, give me an exact price.
95,
$95 exactly or $95 and some cents?
95, 89.
All right, so go ahead and write that up there, $95.89. And because you're a great customer of mine, I'm going to give you a discount today, all right?
Okay.
And I'm going to let you choose the discount. Would you like 10%, 15%, or 20% discount?
20%.
All right, put 20% up there. So you are going to receive a 20% discount on those new shoes. What I need you to do is figure out what the price is going to be now.
Okay.
And you've got Cindy to help you along to get that problem done, and I'll give you 4 minutes to solve it.
Do I get new shoes if I solve it? Okay, so 20%. I'll estimate, like, or should I estimate?
Well, if you want the exact cost, you're going to have to just get the exact
Okay.
cost.
So 89 cents. That's hard. So multiply 95 by 0.2.
Okay.
0.2.
Yeah, that's a good start. What's that going to give you for your, so if they cost $95.89 and you're going to get a discount of 20%, when you get your answer to your multiplication, what's that going to represent? Is it going to represent your new cost or how much you save?
How much I save?
Okay, just making sure
0.2.
we're on the same track.
Okay.
So do you have to line up your decimals when you multiply?
Yeah.
Remember? Only when you add, actually. So you actually could do it.
And I'm going to save you a little bit of time right here. So if you go 9589 times 0.2 for 20%, that's going to come out to be, so draw your line and you can go ahead and put what this is going to come out to be. 19.178. And I gave it to you like that because I want you to round it.
Okay. So this, if it was on like over 5, I add 1, but.
So let's, before you round it, because you are rounding correctly, since this is money, right? This is all about money. How many decimal places can money have?
2.
Okay, so we have to round it to the penny then, right? So we want to round it right here to that number. So we have to decide if that number stays or if it changes.
That number will change to a 0 because, or actually, yeah, it'll change to a 0, right?
So when you're rounding, so basically you're either going to go, okay, I'm going to save $19.17 or, whoops, or $19 and what would this round to? What, you always round up by 1, so what's 1 more cent than that?
8 or 18.
Yeah, so we have to decide, you know, should it stay at 17 cents or an 18 cents? So what do you think? So if you look at the next number, is it big enough to make it change?
Yeah.
Okay,
So
then what would it become?
18.
Yeah, so let's just write it over there so you don't have to.
All right, so now that you've got the discount, I want you to hold on to that. We're going to come back to you guys in just a minute to finish up that problem. Right now, we have one more opportunity. We're going to go back out live to the Bakersfield Museum of Art and visit with Devin.
But it's a grade 7, right?
Hey, thanks a lot, Mike. Back here at the Bakersfield Museum. This might be the loudest I've ever spoken in this space, and I feel like I can get away with it today. Back here with Rachel Magnus, the curator here at the Bakersfield Museum of Art. You know, we were talking a little bit about this piece. Could you describe to us the purpose and the process of the work here?
So this is another artist exhibition. This is actually a local artist who teaches at Bakersfield High School. Her name is Yvonne Kavanaugh. She is primarily a ceramicist. And this body of work was a result of an accident. She was trying to learn or find a way to deal with life and reinterpret it in her making of art. And in order to let go on the wheel, she would let a ceramic piece go around 1 extra time, which would allow gravity to take hold and they begin to collapse.
So each one of these represents a unique and distinct failure in the creation of a vase. And we had discussed during the break how every single one is very unique and creates very unique shadows. And sometimes, you know, some of these failures end up in something really, you know, beautiful and symmetrical and structurally sound that maybe we don't anticipate, but we end up with through the process of trying new things out and playing around with failure. And that ties in so beautifully with math, I think, in the sense that we don't just, you know, do something once and are okay with it. We explore more by trying things that don't work.
Yeah, and that's a lesson we have to keep learning throughout our lives in all different areas.
Rachel, there's always a lot happening here at the Bakersfield Museum of Art. Let our viewers know a little bit about some of the events coming up here.
Yeah, the Museum of Art, we are open every day, Tuesday through Saturday, and we're here from 10 to 4. There are some really great opportunities for you to come. If you want to bring your family, we do have free days. Every first Friday is free and every second Saturday is free. What's great about second Saturdays is we always have a project, an art project that you can do in one of the spaces that relates to one of the exhibitions on display. Additionally, we have some great art classes. We have art camps during summer break, during winter break, and then every other Saturday we have what we call Saturday Studio, and where we focus on a different medium. It's for students ages 6 to 16, and they get to come learn about a medium a bit. Because it is a studio setup, you really get to do things on your own time. You get to play with the medium, you get to create what you want to create, but it's all within the realm of the medium.
So there's a different medium that's focused on each of these Saturday studios. I understand that watercolor is coming up this Saturday.
Watercolor's coming up.
A couple of Saturdays from now, it'll be sculpture art, so you'll get a chance to play around.
Here we are.
And then there's a big event coming up this weekend, I understand.
Tomorrow night, we've got people working in our garden because we're in the midst of transforming our garden into a surrealist circus. It's our last Art After Dark of the year, and every year we do a surrealist masquerade, so we're getting ready for that, which is tomorrow night from 8 to 10.
If people want to get involved more with the community behind the Bakersfield Museum of Art, what would you recommend?
The best way to know what we're doing, we always have something going on for everybody, is to get on our mailing list. We have a newsletter that goes every month, and if you really like the things you're seeing, become a member. Every time you come to the museum, you get in free. You get it discounted prices to our classes, to all of our events, but it's a great way to stay in touch and allows us to keep doing what we do here at the museum.
So let's say we have a viewer at home today who is excited about math, loves art, would love to get into your line of work, would love to explore the pathway to become a curator. What was your path, and what would you recommend as far as a pathway for those?
Curating is a really interesting world. Most curators have some sort of higher education degree in art history, which that is what I have. But there are also other avenues to get there. There are programs like Museum Studies program, because as you've heard today, there's a lot more than just the knowledge and history of art that it takes to curate a space. There's a lot of design, there's a lot of math that goes into this. So a Museum Studies program allows you to dive into all of those aspects of what it takes to be a curator. I am very passionate about history in general and really a creative person, so studying art history was an incredible combination of those things for me. And then being in this position, I've learned how much I love designing the spaces, and that is the favorite part of my job. And I think you can tell I get really excited about creating these spaces. So somebody that really likes math and art, it's a great opportunity for you.
Well, it's a wonderful space to be able to play around with, and we're thrilled that you have the opportunity to do so, Rachel. And to thank you for inviting us into our space and sharing an hour with us and our viewers. As we do with so many of our community members, we wanted to thank you and present you with our traditional and honorary Do the Math tile plaque. So thank you so much.
My parents will be so proud.
You can tell them where to put that, because anytime we do our programs, we are so grateful and thankful for organizations such as the Bakersfield Museum of Art for the opportunity to come and explore the space in a way that a lot of other people don't really get to. So again, thank you so much, Rachel Magnus, curator for the Bakersfield Museum of Art.
Thank you for coming.
Always. And any of the events, check out their website. For now, let's send it back to the studio for the last time today. Mike, take it away.
All right, thanks for that, Devin, and thank you to Rachel, as well as everybody involved with the Bakersfield Museum of Art. We do have phone tutors available until 5:30 this afternoon, and we want to say thank you for Tanveer coming in. Did you have a good time today?
Yeah, I had a great time.
All right, you know what? You are now an ambassador for Do the Math. With that comes a uniform. Have you ever had a uniform before?
No, not really.
Well, now you do. It's a big day for you right there. So you've got yourself a uniform. You're an ambassador. You need to tell everybody about Do the Math. Can you do that?
Yeah, sure.
All right. Well, you know what? Let's take a look at your problem. You had the shoes for $95.89. We took off the discount. So what are you going to pay at the end of this whole thing?
I'm going to pay $76.71.
There you go. Nicely done. He did the math, and until we meet again, you continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.